Let us discuss this result. See, here we have two matrix spaces x d1 and y d2. With the help of x and y, product metric is defined. See, in case of product metric, there are different definitions can be possible, but here they have defined this product metric in this way: d1 of x1 comma x2 plus d2 of y1 comma y2. What we have to do here, we have to prove that any sequence x and y is Cauchy in a product matrix x cross y if and only if sequence xn is Cauchy in x and sequence yn is Cauchy in y. See, if and only if is there, so I will assume one part, first part, and we will try to prove the second part. The first part I have already written. I have considered xn comma yn is a Cauchy sequence in the product matrix space x cross y. I have taken epsilon also greater than 0. So by definition of Cauchy sequence, what can we write? So therefore, there exists n belongs to set of natural number such that, what can we write? Such that d of xn yn comma xm ym less than epsilon for all n comma m greater than or equal to capital L. After that, what will I do? I am going to use the definition of D. Definition of D involves D1 and D2. D1 will operate on elements of X, D2 will operate on elements of Y. So if I follow it, so we will have therefore D1 of Xn Xm by definition of D, getting, and plus D2 of Yn Ym, which is less than epsilon. This is less than epsilon for all n comma m greater than or equal to capital N. We are adding two non-negative terms and their sum is less than epsilon. That means each term is less than epsilon. So therefore, d1 of xn xm less than epsilon and d2 of yn ym less than epsilon for all nm greater than or equal to capital N. Therefore, sequence xn is Cauchy in a matrix space xd1 and sequence yn is Cauchy in matrix space xd2. These are simply definitions of Cauchy sequence. So therefore, sequence xn and yn are Cauchy in xd1 and yd2 respectively, right? See, in this way we proved half part of this result. Okay, make a screenshot of it, please. Conversely, we are assuming xn and yn both are Cauchy sequence in matrix space xd1 and yd2 respectively, and we have to prove that xn comma yn is a Cauchy sequence in a product matrix space x cross y. Let us start. Okay, the assumption already I have written here. Let us take epsilon first. Let epsilon greater than 0 be given. So here we have two informations. Xn is Cauchy as well as yn is Cauchy. So therefore there exists, I will say, n1, n2 belongs to set of natural number such that, see, I assume n1, n2, two natural numbers I have assumed, n1 for sequence xn and n2 for sequence yn, such that, see, d1 of xn xm less than epsilon for all nm greater than or equal to capital N1 and d2 of yn ym less than epsilon for all nm greater than or equal to capital N2, right? See, simply I use the definition of Cauchy sequence, but a small adjustment I am going to do. That is, instead of epsilon, I will take epsilon by 2. It's a adjustment, okay? And yes. So see, two natural numbers we have got. So I will take maximum of n1 and n2. So that means both of them will be true simultaneously. So let n is equal to maximum of n1 and n2. So that's why we can use both statements simultaneously. Now consider n comma m greater than or equal to capital N. We have taken maximum, so that's why we can use both. So let us consider d of xn yn comma xm yn. I have considered in this way. Okay. See, So this is a product metric. This is a product metric. So you remember the definition of product metric in a given example they had given. It is equal to D1 plus D2. D1 will operate on elements of X, D2 will operate on element of Y. So that's why this is equal to D1 of Xn Xm plus D2 of Yn Ym. Getting? So D1 of Xn Xm is less than epsilon by 2. This is less than epsilon by 2. D2 of Yn Ym, that is also less than epsilon by 2. This is less than epsilon by 2, which is equal to epsilon. So therefore D of Xn Yn Xm Ym less than epsilon for all Nm greater than or equal to capital N. So therefore we can say, yeah, X and Y is a Cauchy sequence in a product matrix space X cross Y. So therefore X and Y is a Cauchy sequence in X cross, okay, I should write X cross Y D. So in this way, in both ways we prove this result. Okay, so make a screenshot of it. After that we will stop. Thank you. Bye bye.